So thanks for everyone for joining with us on today's webinar. So this is Lokesh here and have my panelist Karthik Malreddy, who is our data science expert and the solution architect who will be presenting today's demonstration. And we have got Wally from the KNIME team, who's again a solution expert and architect on the KNIME side. So we three will be mostly talking today on the whole demo we want to showcase to you guys. So let's get started. And if you guys have any trouble in the video or the audio or any of the things, please put your questions forward in the Q&A, of course, along with the questions you might have in the course of actions on the demo and the demonstration. So thanks for everyone once again for joining with today. So as we get forward, so Karthik, can you please help me start sharing the screen, Karthik?
So this is the Q&A section, which users can use it.
Let me share my screen quickly so that we can get started. And Karthik, you can take it from me. Yeah.
Sure. Yeah.
Great. Thank you, guys. So give me a minute. So is it in the full screen? Karthik, let me know.
Yeah. Very good, Lokesh.
Okay, fantastic. Okay, guys. So here we go. So the Q&A section is something that is available in your Zoom. So you can see it in the very bottom pane of it. You can post your questions and we will try as best as our limits to answer all of your questions during this demo sessions. And if anything left unanswered, we will definitely follow up with you guys and get it This session is completely recorded and it will be available on YouTube post the demo is complete. And we will also send up a follow-up link with all the links and the promo codes and the downloads that you guys can get access from the KNIME as well as from the demo part of the things. So as you see, this is a quick snapshot of how you guys can go and access the Q&A, which is there in the Zoom side. So you can see here that's questions and we'll try to answer as much as I said during the live session. And if anything pending out, we'll reach out to you guys. Start with a quick agenda for today's webinar. So we'll give a short introduction about who we are as a data consulting and data partner. We are Akira Insights, and then I'll be talking shortly about the KNIME as a platform, and then we'll give a broad description and problem statement about this user persona identification, and then deep dive into the machine learning models we have used. So Akira Insights. So who we are? So we as a company started in 2014, primarily focusing on providing services to our enterprise customers across the globe. And primarily we are, someone who has been proud to say that for the last 6 years, there have been different challenges in data analytics we have been solving to a lot of our Fortune 100 customers across the globe. We are headquartered in Texas, USA. Offshore delivery center in Bangalore, India. And we work with different types of verticals and industries. And some of the strong verticals and industries we have been providing our services throughout this course of 6 years has been with the retail, FMCG, banking, healthcare insurance, and also with the manufacturing side. So that's been our forte so far. And regardless of whatever the step or the journey that our customers have taken in the data analytics, we understand the maturity level and try to help them in the consulting and also get them to the stage where they can start acting a better business decisions around it. So that's where we came in as a strong partner to a lot of our enterprises who are trusted on us, and the journey has been fantastic so far. And this is a bird's eye view of what we provide as a 3 set of towers in our service offerings. One is on the data engineering, and the next is on the visualization, and the last one is on the data. So this is exactly what we do in our day-to-day life. This is the bread and butter for us. So we focus and specialize and deliver to our best of our quality using the different tools that you can see in the downside, about different partners we have, different technologies we adopt with different clients. So that's pretty much our offerings here.
Lokesh? Just a moment. Your mic is cutting in and out a little bit. Can you do some adjustments there?
Sure, Lindsay. Thanks for bringing it up. Can you hear me clear? Is it audible?
Now it's doing well, but it kind of cuts out every once in a while. So,
Okay, I'm really sorry, guys. It's been raining so crazily in Bangalore, India, and there's been a lot of disruption. I'm sorry for that.
sounds good right now. So let's go.
Great. Thanks, Lindsay.
Yeah.
So as I was explaining, this is a three towers that we provide service offerings with the partners and technologies tools, which is down at the bottom. And then before we get started with this whole demo and the problem statement, what we're going to solve. So we have a kind of enabler within our whole principle of consulting. Say, how do we look at the the good data from any of the enterprise systems? So we have solved a lot of problems with a lot of customers in the past and in the current future. It's all about getting the right data and the good data before we start bringing any effective insights. And we have certain frameworks and accelerators we have put in place to enable this as a good success practice. So with that, our partnership with KNIME has been a really fantastic journey so far. We, along with KNIME, has been working on different domains to help the customers in their data science use cases and building end-to-end data science models. So we are not like like more like individuals who solve a particular problem within a data science. We come in as a more of a partner alliance to our customers who solve end-to-end solution within the data science journey. So, and that's how we have been like more successful in delivering the end stories to the customer by working with different types of use cases, be it on-premise or on the cloud or the big data solutions. And also we have worked extensively on the KNIME different tool sets, which Karthik will be lately talking about in the demo. And that's something which we brings in as a more of a credibility to how we can provide it at the the end-to-end use case solvents. So that's about us, and I will Karthik, over to you.
All right. Thanks, Lokesh. Share my screen.
Yep, please.
Okay. Let me quickly move to this one. Yeah. So hi everyone, this is Karthik. So I'll give an introduction about KNIME first, then we'll go into the use case and the demonstration. So about the tool, primarily, so KNIME's software stack comes with two major components. One is KNIME Analytics Platform and the KNIME Server. KNIME Analytics Platform is kind of a client version where we can use to create data science workflows. KNIME Server is something to productionize those workflows with deployment, automation, model management, retraining the models, and collaboration, all that stuff. So going in little detail of KNIME Analytics Platform, so it provides various nodes, up to 2,000 nodes that we get, which are backed up from the KNIME community, being it as open source. We have a very strong community-driven integrations and extensions, and also we have partner extensions and also the in-house extensions that we get. So which enable us to do the data gathering and data transformation and modeling and visualization. So let me show you the various integrations that we offer. Yeah, so basically all those verticals from visualizations to deep learning neural networks to big data environments and the third-party AI models like H2O and the enterprise systems with cloud marketplaces. KNIME can be hosted on the cloud of AWS and Azure, and also the leading programming tools like Python and R. So it supports all those integrations, which is very convenient. And not just that, it's not just only for data scientists. Even the citizen data scientist or a data engineer or even a business analyst can use KNIME as a data science tool. And KNIME Server enables all these various roles in the organization to collaborate, create, and also enhance the models and share the data science across the organization. That's what very good about KNIME here. And yeah, this is a very standard traditional workflow that we see for any of those use cases in ML. So we have various sections here: data access, transformation, analyzing, visualization, and deployment. So for each of these areas, we get ample number of nodes for each of those analytical workpieces that we need to build. So that's a flexibility KNIME offers. So these are some sample names that you can see here for the data access, from MySQL, RDBMS to the JSONs or to the social media or the big data. Everything is there. So there's a lot of integration availability with the KNIME in-house. So that's about KNIME, pretty quick, for the developer standpoint of view. So moving on. So yeah, so this is the various use cases, for instance, okay, which Akira can build and do a solution for you. And we have done for customers already, and by using KNIME as a platform. And today we'll be looking at customer engagement or customer segmentation primarily. This will be the use case that we'll be referring to. This for your reference. All right, this is the use case we'll be talking about. Lokesh, you want to take it up first before we dive into the demo?
Yeah, sure, Karthik. So if you can just move to the next slide.
Sorry.
Yeah, great. Thanks for that. So guys, so today's demo is particularly the previous one. Sorry. Yeah, there was a bit of lag in my end. Sorry for that.
Okay, sorry.
Yeah. So this use case is typically for anyone who has their customer data and they really want to understand how their customers are doing within their, the whole cycle of the journey within your own enterprise, right? So that's where people are more interested. Who are my customers? What are they doing with me? How am I going to get a more better engagement ratio with them, or the more conversions with them, or how do I reach out to them better? So this has always been a challenge to enterprises, and of course the enterprises has been investing a lot, be it tools, be it the campaigning they're trying to do with different forums and digital social sites. It's all been there, but have they reaped out the entire benefit of what they've been doing? It's always questionable when it comes to the ROI and the effectiveness of it. So that's where the data science has come and played a significant role in the last couple of years to say, do you have all the set of data points with you to actually see what you have done in the past and what you're planning to do in the future? Is it going to give you the right set of benefits or the right set of implications for you to invest more on your customer life cycle? So that's what this use case is all about. So Karthik, if you move to the next slide, I'll just queue up. Yeah, so the problem statement here today, we are talking about a retail and consumer product goods as a customer, and they are one of the global sports retailer whom we have been working with for the last almost 5 years. And the challenge here for them is they have so much of user community and the sports users from their customer base, and they have a very less idea of how to target and appropriately do their campaigning and marketing strategy to them. Of course, this is not just for purely for the revenue increase. Of course, that's one of the key areas, but also till who are the people that they have to reach out for their other side of services they provide, like be it coaching or the sessions or the playgrounds which they have they have to get occupied with. So all this has been a fundamental challenge for them in terms of how do I kind of take this data and massage it and get me a right outcome out of it. So we approached this problem in a different way, saying, why don't we kind of build a model around it to understand how the customers can be segmented out first. There are different types of customer available in the market and who has been enrolled with you. So here we are doing a bit of segmentation to give the perspective to say, hey, these are your customers who are fairly new to you and who has been kind of interacting with you in a different sales life cycle, and they're not buying products on a regular basis with you. So these are one set of groups. And there are real active sports customer, you can say your loyal customers or regulars who are purchasing products and who are also been engaging with you in different sessions and coaching and whatnot. How are we going to classify them first based on what kind of parameters is what we are going to show to you, information to them, because you don't want to run a marketing or a campaign strategy for all the users, with the same message, same kind of posting, right? So you want to kind of give that personal feel to them. So let's say, for example, I'm a cricket player. So I would like to know what are the sessions that, this client is offering to me, at what places, how am I going to get it? What are the regarding to the cricket? So how am I going to get all this? So that customization is more important in today's world for every customer. And that is what exactly we're trying to get out of the segmentation, to tell the business, hey, these are your customers. You have to customize them with this kind of campaigns, with the specific kind of messages you have to pass into. So to improve your first, the customer conversion for you and the engagement continuation for you. With that, obviously, what is the outcome out of it? The quantifiable outcome is going to have of course, you're going to see an increase in the sales because people are going to, read about what you're sending to them, and they're going to come in and start buying you your products, and also help in increasing your indirect set of services, like be it the sessions or the coaching you're doing. So that's a business outcome we have achieved out of it, and we are happy to say the customer with whom we have been working on this has achieved a 26% approximate contribution on their overall services in the direct and the indirect point of view. So that's more about this particular use case. And please bear in mind that this is not specifically applicable only for the retail and consumer goods. It is applicable for all sorts of your industries wherever you have a B2C customer interaction, be it your banking, be it your insurance, be it your healthcare. Wherever you say you're talking to a customer and you have your rich customer information with you in your marketing forum, and also your sales data available with you, you can just mix the data, massage it, and put it into the right model to get this desired outcome. So with that, Karthik, over to you on the demo. And guys, we are happy to take questions. As I said, like, we have a Q&A section in the bottom. So if you have any questions about the use case or anything that we have spoken so far, please feel free to type in over there. Thank you.
Thanks, Lokesh. So yeah, so as Lokesh was explaining, so there's a requirement for customer, the problem statement, right? So customers has lots of data, and in current big data era, so there's lots of data lying around. So we need to just make sense out of it, and the customer's requirement is specific to that. How to get a segment of customers to whom I can extend my new services or get them back to the current, e-commerce or the store purchases. That's the whole requirement. So for this, what we have done is, so we just done the segmentation of the customers by using K-means clustering, and I'll explain the solution on a high level as of now, then we'll go a little detail while doing the demonstration. So the first step of what we've done is, we've done the first level of clustering based on certain features, like the overall turnover the users are making, and the number of receipts they have made, and the number of unique products they're purchasing for any given sport. So that will be the first cluster that we build. And from there, we'll pick the cluster, which we call as sport user, the cluster which has more probability for a better business to go into the new services or the existing services. So this cluster we further split in the second level of clustering into 3 levels: pro, intermediate, and amateur. And these levels are not on their sport capabilities. They're on the level of how probable these users can come back to us or with the new services or the existing services purchasing. So the pro means they have a better probability. They can be our new customers for the new services. So that's what this leveling means. So this is a high-level solution approach. Let's understand a little bit on ML and the K-means, and then we go into the demo. So moving forward, machine learning. So, okay, this is a overview of machine learning. So probably some of you guys already know about it. So supervised learning is one of the branch of machine learning, along with unsupervised, which we cover in today's session. So supervised learning primarily focus on training the model with a labeled data, right? So what is labeled here? I'll just try to understand that. So let's say there is an image of a cat, just to put it in a very simple example, and the image has a description saying that it is a cat, right? So that's one label. And maybe another could be saying that it weighs 10 pounds. So that would be another label for that. So that image is having 2 labels, and that's what is labeled data. And let's say the image doesn't have any descriptions. So then that's unlabeled data, to be specific. And supervised learning uses a labeled data, okay? So which means when trying the model, so basically supervised learning is based on training data, and outcome or output for the given input is known before itself. What that means is, when you train the model saying that this image is a cat, then when we reuse the model for the output with the new inputs, with a similar image, the model will tell us it is a cat. That's all. It's just training the model and getting the output. Instead of a human, a machine will give the output. That's what the supervised learning in a very simple way. And primarily, we'll have a couple of models that we use, regression or classification. And a very good example for regression technique would be the house pricing. So if you pass a couple of parameters or features like the housing square feet or the number of bedrooms and all that, or the locality, then we'll get an approximate price from the model. That's a very simple or standard example for regression technique. We can use classification as well for certain other examples. Classification mostly describes about state, whether it's a true or false, yes or no. It works on the discrete model. and a regression is more of a continuous model. So that's about supervised learning, very high level we're going. And going to unsupervised, it's somewhat opposite to supervised what we have. And here we don't do any training to the model. We just leave the model to discover the information on its own. And we use unlabeled data here. So for example, let's say you're passing some 1,000 images of various animal pictures, and the model will identify all those pictures and group them, all the cats into one cluster and all the probably dogs into one cluster. So even in a case where we don't have the label data, we still can make sense of data by figuring out the insights from the data. And in today's world, most of the data is unlabeled data from the big data era. So that's why unsupervised learning will have its stand in a prominent way in the current ML models. And one of the primary unsupervised learning that we use in today's examples is K-means clustering. And I will look into what K-means is about. Right. So K-means is an iterative clustering algorithm which helps in groups data points into K clusters. So K in K-means is nothing but the number of clusters that we make out of any of the model. And when we start any model, right, so we can't decide on number of clusters straight away. So we need to do some data analysis, look into data spread, is it dense or wide, look into all that, and and also the requirement of the use case. In this particular use case, we're looking at two segments in the first clustering. So we'll go with 2 K-means. And in the second clustering, we'll use 3 K-means to define the 3 levels. So the number of K depends on the requirement or the business use case and also how the data is spread. So that's the first step that we see here. And let's understand the flow here first, okay? So once the K-means algorithm has started, the first thing is we'll define the number of clusters, start data analysis. Then we have to initialize the centroid with a random seed. I'll explain what the centroid would be. And then the distance between the data points from centroid to individual data points would be calculated by the algorithm. And all the closest data points for each of those centroids would be grouped as a cluster. And this cycle repeats until there is no further movement of the cluster. So centroid is nothing but data point, which is a mean, those closest data points in those cluster. So I'll show you what I mean in a couple of minutes, okay? Right, let's go to this one, yeah. So in the first image, you can see all these various data points, right? The circles are the centroids and the squares are also data points. But these 3 circles that you see, red, green, and blue, are the random seeds that's been initialized as centroids. Now in the first iteration, if you see in the second picture, okay, the first data point of the square is being grouped as a red because that is closest to red one. And all the other here is in the green and all here is in blue. That's a simple first level of clustering. In the second iteration, the centroid, which is again a data point, moves towards here because this will become a new mean in that red cluster. Okay, that's a new average over there. So it moves here. So in the second iteration, now this red circle is a little closer to the first green at the border here. So now this will be pulled towards the red cluster, right? So that's how the third cluster, second cluster forms. Sorry, second iteration of clusters forms. Now this cycle will repeat again. So for every cluster again, the new mean will be calculated and the new centroid will form and all the closest points will be grouped towards that new cluster again. And the cycle repeats again and again. So till there is no further movement in the centroid. So that's how the K-means works, and so it groups the data. And one more point to notice here is how the distance is measured in the K-means. So this is the Euclidean distance. It's a mathematical concept that the algorithm used to identify the distance. So let's understand the distance here very quickly. So if you have 2 points in an axis, okay, let's say these are 2 data points in the axis. So using this formula, the x2 minus x1 square plus y2 minus y1 square will be useful to identify the distance. So in this case, it would be 2 minus 2, which would be 4 square, and then minus 3 square, which will give you 5. So in this way, the distance will keep getting calculated between each data point with the centroid, and which are all the closest to the centroid will form one cluster. Okay, and if we give 3 K-means, which is 3 clusters, then the algorithm works into 3 clusters by identifying the distance. So that's overview of how the k-means clustering works, right? So yeah, with this understanding, let's dive into the demo now. So you guys can use Q&A for any of the questions. And we'll also have a Q&A at the end of the session. All right. So, okay. So let me explain about KNIME Analytics Platform for how the IDE works and all that a little bit, and then we'll go into the workflow. So this is the KNIME Analytics Platform here. So all you see in the left side, these are various workspaces, Okay, the first one is KNIME Explorer, where you can have all your workflows. And as I was saying, it's an open source, and we have a KNIME Hub where you can connect to the the technical guys out there and share your workflows, and you can also use their workflows or the notes into your workflows. So it's all collaborative. Then the second is a node repository. So this is where you see all those integrations which I talked about in the slides. So primarily, if you see the input, it talks about file-based integrations. Then there is a DB integrations, and we have lots of all these various machine learning models ready-made. You just need to drag and drop and do a little bit of configuration. That's it. You're ready. You're good. No coding required. So it's pretty easy for any new guys who is coming into data science, and also to explore a lot on the data science. And if there are any existing Python or R programs or Java or even a PMML coding, we can integrate that into KNIME, and similarly we can extract the PMML from the KNIME to other platforms if required. So yeah, so these are various things that you guys can explore. Okay, so and yeah, visualizations we have for this. Let's moving on. So then we have console, which shows the ongoing things here. Then another good thing is the description. For any of the notes that you're going to select, you can see a detailed description of how it works and the various configuration settings. So it's pretty handy for any new guy starting with KNIME. And then there's a node monitor. This is something to understand the execution of the nodes live. While executing, you can see how many iterations the k-means has executed, or how many loops if condition has been executed. So all this can be monitored here. That's a node monitor that we have. Now let's start with the actual workflow now. All right, so if you let me zoom out a little bit. So you can see 4 primary sections here. The first one is the data transformation and data extraction and transformation a little bit. Then there is a clustering, first one, and the second clustering, and the final output that's being inserted into the database. In between each of these yellow boxes that you see, there are small meta nodes, which I'll explain in a bit. In this, we have the data transformation nodes, which were grouped together for a visual. Let me dive into data source. All right. So here we're picking the data from our PostgreSQL, and as we've seen, it supports all the RDBMS sources and the big data and file related sources. Before I start, let me reset all the nodes. So what I mean is when you execute the flow execute the flow successfully, it stores all the data in the memory. So when we reset, it releases and we can redo the execution. So let me go to here. I'll just do reset. So when I do reset, you can see the red marks here, which means they're not executed. And yellow is something that which is ready for execution, and green is a successfully executed node. So let me execute this first, so that all these will become yellow, because now they are ready for execution because the connector is ready. So let me show you the connector. So most of the nodes that you see in KNIME doesn't need any advanced configurations. They are pretty specific and pointed to what they do. So you just need to give a simple configuration settings. In this example that we're doing this one here, the host username and password. So connecting to this, then we have DB selector. So here we're demonstrating that we can connect to database and pull the DB tables, either using a SQL, where you can write your custom code of joins, or any custom groupings, anything custom code, you can write it here. So that's one way to pull, or you can pull the table directly and do all those joins and all here in the KNIME itself using a joiner. So we'll demonstrate both. So the first DB selector uses a query, second one will pull the table directly, and then we are reading the data. The first node is just reads the metadata, and this actually reads the data into memory. So the configuration settings here is to store the to store the data in the memory or to store the data into the disk. So usually we use memory or the disk based on the configuration that you have in the server. So let's pull the data for the first one. Right, so it's executed. Now this one, let's see. So now we have data in the memory, which is ready to use for the next nodes. This takes some 30 to 40 seconds. Let's look into other nodes in the meantime. So joiner is what we're using to join those two data sets. So one is our SKU information, other one is the transaction information on customers for the geographical location. So all this sales information we are pulling and joining here. And then we're doing, let me run this one as well. And we're grouping all those measures based on for each geolocation, sport ID, and customer ID. We are getting a manual aggregations for sum or counts for each of those measures. The total quantity, total net transactions, or unique models the user purchased, or the total amount they have made. So yeah, so it's pretty simple. You can do all these transformations here. So we're running this. So with this, we get our primary data set, ready for further execution of clustering. So that's what the whole data extraction is about. And so one thing here, so we can see the output. So you can right click on the node. After the successful execution, we can see the output for each of the nodes, and you look into all the data and the row IDs it has. So all this is pretty straightforward. Okay. So this is very useful to basically track the data, how it changes, how it transforms from node to node. And you can see other flow variables in case if anything is defined. Flow variables are kind of variables which can be defined globally at a workflow level and can be used to assign a specific value from a node to a node. I'll show you that in a bit. Okay, let me close this. All right, so yeah, so our data extraction is ready till here. So the next thing is, this is basically kind of a counter, a loop counter. Let's think about it as a while loop, okay? So why we are doing a loop here? So our logic is to build the customer segmentation for each of the sports. So in this example, we have taken a couple of sports, okay, for the time benefit. So in these two sports, the loop executes twice, once for each sport, and do the customer segmentation. So for each geolocation, for each sport, with those three features of turnaround amount and the number of unique products and the number of transactions the customer has made, using those features, we'll build the clustering. So that's why we are initiating the loop here. We are saying use the sport ID, okay, which is, let's assume that one is cricket, one is tennis. So first time it runs for the cricket, right? Then there is a node just to initiate the loop. There's nothing specific to configure here, just saying the system that let's start the loop, right? So from here, then it goes to data preparation. So let's see what we have in data preparation. So before we start any machine learning models, we need to do some kind of data cleansing or massaging, okay, to have the data in kind of equal levels. So for that, we do data normalizing, right? So you can see the data filter here. The red line that comes up here is a flow variable. So in this loop, let me execute the loop start here. So loop has started. And if I see the output here, so the first loop is for the sport ID 428. So 428 has been picked into the memory, and that 428 value will be passed to the row filter to filter the data set, because we are picking the two sports from our data source. So here we're filtering to that specific sport ID. Sorry, so let me execute this first. I can do it here. So I'm just running all this. So now data will be filtered to only 428. All the other 458 data is excluded. So yeah, KNIME provides all these row filters, column filters, rule-based filters, math formulas. You can do a lot of customization. So here from the rule filter that we used is we don't want to use all the sports or all the geolocations which doesn't have good enough data. So we have written a formula here to avoid the data sets where there is not even 100 records. So that's what this is about. And we can customize it as per the requirements. Then there is another formula to build. This is to exclude the outliers. See, in K-means clustering, if you have all dense data somewhere around, let's say, if you take an example of 1,000 to 10,000, but there are a couple of numbers which is at 10, 100,000 or 200,000, that will disturb the whole clustering logic. So that's why we'll exclude the outliers with the explanation that it doesn't affect the logic, because we have our 99% of data clustered at one single boundary. So that's why we exclude the outliers. So we're identifying the maximum transaction quantity and the mean, sorry. And then let me undo this, yeah. And then excluding the data out of it. Let me show you how the other filter here. So we're just taking the total quantity less than the max equal to true. So if anything is, we are defining a max boundary, and anything less than that should be true. So any outliers out of this max quantity are excluded. That's what this is doing basically. Filtering the data set, prepping for the cricket sport, then excluding the outliers and normalizing the data. So what is the normalization, right? So now we have these three parameters. The turnaround, the total turnover, and we have the number of unique products, number of transactions. Usually the turnover, let's say it's in thousands of dollars, assume, and the number of products could be in tens, right? So if you plot these data points in a graph, let's assume a three-dimensional chart, they won't fit in the same space, right? So that's why we normalize all these values into 0 to 1 in between, right? So then we can plot it in a uniform way. That's what this normalization does. And we give the mean and max to 0 to 1, or we can use any predefined normalizations. Z-score is one of the popular one, which can be used. So that's what this data preparation is, filtering, excluding outliers, and doing the normalization part. Now coming back to the main flow, and this is where the K-means clustering starts. So the input from this one to here, so we're just configuring, saying that we need 2 clusters, okay, and we can, we're just doing a random initialization of the seed. We can use any number, and the max iterations is 150. You probably usually can use about 50 to 100 or 150 based on the data, how dense it is. Maybe if it is too narrow and too dense, you don't need so many iterations. So it all depends on how the data is, right? This is just random. Even if you mention a higher number, the logic will stop executing once the centroid doesn't move further. So you don't need to worry about that. All right, so yeah, so these are the features that we are using: the revenue, the total models, and the transaction count. Okay, so we don't have any flow variables, and we are storing in the memory. That's simple it is. You don't need to write any huge code. Okay, it's just as simple as this. And let me execute this. Right, so the clustering has been executed. If you notice the node monitor here, so I've selected the node and it's been executed 2 times. So within 2 times the centroid got fixed and there is no further movement. So that's how the node monitor will help us to understand the underlying operations. And yeah, once cluster is ready, so this is just for demonstration purpose, how we can extract the PMML out of it. So we can see the output of K-means. So this is a labeled input. We can see all the input parameters, the normalized values, which are all between 0 and 1. Okay, then the clustered output, cluster 1 and cluster 0. Right, these are 2 clusters formed from the K-means output. And we can also see the mean values of those clusters for each of the feature. So these are pretty useful. And actually plot them into a scatter plot and see how they are spread across the graph. So to decide which cluster is better. So there are 2 things here. We're not just doing a clustering. We're also doing identifying which cluster is better or which cluster has more probability to, to come back for the new services or the existing services. So in this case, if you see the first, the first cluster has a better values. But again, we are not doing it by eyeballing. We are doing it mathematically here. That's what the next 4 steps here. So we are extracting the data, all this data here that you see in the clusters. Sorry, go to the details. So all this data that you see here, the detailed ones, we're identifying the mean of it. That's what we're doing in the group by. Quickly, I'll execute till here so I can demonstrate. Okay, so we're just grouping all this and finding the mean of these. Okay, for each of the clusters, cluster 0 and cluster 1. Once we get that, we're finding the average of all that. Okay, then we're writing a formula, identifying the max. and the max is given as 1. So for the downstream code or clustering, we use only where is player equal to 1. So the process, what we're doing here is we're identifying the base data and finding the average and the max, and which has a better mean. We are taking that cluster or that group of users to the next level of clustering to identify the levels, the pro, beginner, and intermediate. So that's what we have done here. And the further steps, these are pretty much similar. The next 3 to 4 steps that you see here as what we've seen in the prep of the first clustering. So I'll just quickly go through that. So in output, we are filtering to the is player equal to 1. So the cluster has to be, yeah. This is basically we are appending the data from the original to the clustered output. So to get the country ID and all that. Then we are filtering out the normalized columns, which we don't need for the final output. And then we are filtering out for the is player equal to 1. Is player equal to 1 gives that best probable cluster for the downstream code. So that's done. So with this execution, now we have one cluster of data, which is having high probability, to come back as for the new services. So then there is a second step of data prep, which is pretty much identical to the first one that we have seen. So where there is a rule-based filter to exclude any data sets which are not having at least 50 rows. So that's for the second cluster. Then we have column filter to exclude the rows which are not required for the clustering.
Yeah. Hey Karthik, this is Lokesh here. Yeah, in the interest of time, I think can we just move a little fast?
Yeah, sure.
Yeah.
Okay, guys. So this repeats as the first one that was seen. And the second group is k-means clustering to define the levels. So let me execute this. So, yeah. Sorry, guys, I missed the clock here. So let me cover it up. Okay. So now again, yeah, we have the same features, the revenue, the number of models, and all that. So with this output, again, we get the clusters, the 3 clusters, the beginner, intermediate, and the expert. But we were not able to identify them directly. So we need to define this mathematical logic again here to identify the mean and then the average, the max, then define the levels here, okay, the min, max, and all that. So with this, the cluster which is having the 1 value will be the high probable user set who can come back as a repetitive user for the new services. Execute till here. Got it. That's all. With this execution, we have 2 clusters of user sets and also the levels defined. Then this is the data preparation, just to insert data into the data database, just to little cleanup, excluding all those unnecessary rows and then adding some timestamp. All right, this is where the loop ends. So if I zoom out, so the loop is starting up here and ends here. And if it goes for the second iteration, let's say for the next sport, the tennis, right? If there is not enough data, there is a if condition that we have used, which goes to the exit loop, okay? All right, so we're inserting the data set again back to our Postgres. Okay, let me run this. So basically it's looping the second time. So yeah, that's why it took time. Yeah, so data got inserted into the DB. All right, let me quickly show you the data here once. Okay, let's just. Sorry, yeah, typo. Okay, see, this is the output that we got from the model just now. and the same output can be published into a Power BI or Tableau datasets or any Excel or PDF reports as well. So if you see the first one, let's say this is one of the sport ID. Let's assume it says a cricket. So we define 3 levels, the pro level and the intermediate and the beginner. So we can see, I can show you the raw data, in interest of time. So for 4 to 8, there are about 250K of records, 250,000 records, out of which we identify 10% of users as a highly probable that can come back as customers. And we also find about 10% again as intermediate and very least as the low level. The other sport, we can see it's about 15%. Even this sport consists about 240K records in the raw data. But the second level is very low here. So it's most of them lies in this section. So this kind of analysis that we got, and the same can be plotted into the visualizations as well and deploy into the KNIME server to further share with the teams. All right, I'm just pushing it here. So yeah, that's all on the technical implementation, guys. So
yeah. Yes, Karthik, I just want to chime in. So guys, sure. I know this has been a very long technical demo from our side. And of course, thanks Karthik for a detailed walkthrough. I'm sure people who has been, kind of looking forward for more of how do we build such kind of things using KNIME and using data science tools. I'm sure you guys would have got a little more experience about it. We have put the slides in the whatever we have presented in the slides as well, which we'll share it along with you guys. But I think the whole crux of the story from what we have built out of this demo, and as I started at the beginning, is how do we help our clients who has this whole customer base, be it like, thousands of customers or millions of customers at their point of view. How do they go and help those customers in their whole servicing aspects? Either get them into better engagements, better conversions. And today we are talking about so much of money is already being spent on CRM systems or digital marketing content. And also, so much of data is gathered over there. So what are we doing with this data? That's a real question. I think, the customers or, the clients are looking for themselves, are we really using the data which we already have in these digital applications or the forums or the data places where we already have to consume and build such kind of models, what we presented today, and get a meaningful information. So here, the customer was quite happy with the way it has come out because one, they have this information about, what is my customer? Okay, what are the kind of products they buy? But what are they going to really do about it is the next question it comes to the mind. So that's why this segmentation of, identifying who are your pro, intermediate, and, the beginners will help them to really tell these are the products which is, upcoming for your sports choice. And these are the things that you should start with. So again, giving that, that justification to the customer. Why do you invest in this kind of products? Because of your skill set. Because there are a lot of times we buy some product and we say, hey, probably I should have bought a different product. This is not my choice. Or rather, if I know more about this product, I wouldn't have bought this and I've gone for another product. So these are some, most of the choices that we make at the end of the day when we buy the product. Now, how do you enhance that customer experience? Of course, if you do this kind of insight analysis of saying segregating your base of customers and identifying and telling them where they fit in, from their previous experiences with, the buying cycle or the campaigns they have engaged or the sessions they have attended with the particular client here, we can always tell them this is the right journey for them. So that boost up their, the overall program loyalty for them with the customer, boost up the sales, and also gives a brand value for the overall space. And typically in the current pandemic situations, now the retail stores are almost, out of place, right? There is no brick and mortar stores, which has been operational, fully operational, I would say, for the last 4 months. Now, how are we going to reach out to your customers at this kind of situations? I think these are some of the activities that, our clients are looking at. Hey, I have volume of data. Can you please help me to mine so that I can do a right campaigning to my customers, right kind of message passed to the customers? I think that's where this kind of solutions holds its high value. And with that, we thank all our panelists for helping us out in putting this demo together. And thanks for all the attendees. I know we are really ran out of time, but we are happy to take any questions for the next 10 minutes, and then we will answer it post this. Anybody from the attendees, any questions that we can take, both functional, technical? Hope we didn't make you guys sleep in that presentation. Karthik, I think Karthik and Wally, I think our people. Yeah. Do you want to guys?
I just saw a question from Joe. Hey, Joe. Right. We can use scatter plots to plot the data. Is that what you mean for the k-means output, or even initially to analyze the data to see how the data is scattered? Before we start with the k-means. Yeah, we can use that. That's a very simple, or classic visualization that we can use. Yes, yeah, even after we separate them as the clusters, yeah, we can use scatter plot.
And just to add to that, you could also apply some color managers so that you can kind of visualize where your clusters are, right? I think so.
Yeah. Well, you can take this one.
Yeah, so Harsh asked us performance of the analytics platform. How do you manage if many loops are to be run on millions of rows of data? So within KNIME, it's always going to be dependent on your machine and kind of how the workflow is set up. So if you have millions of rows of data, for example, one of the features that we offer is streaming nodes. So instead of trying to process all 1 million rows at once, you can process them kind of sequentially, and then you can do chunking as well. So those go hand in hand, where instead of doing millions of rows at a time, you'll do a couple thousand, 100,000 or so, depending on the performance of your machine.
Okay.
I don't know if we mentioned it, or Karthik, if we mentioned it, but I would encourage all of you to download the analytics platform. It's open source. It's available. You can download it from our website.
Right, and we'll be sharing the video as well with the team along with the presentation. So yeah, you guys can try it out. Okay. How can we deploy this algorithm built in KNIME? So yeah, we have a deployment option built into the KNIME Explorer. Maybe let me share my screen. I can quickly show you that. Okay. So yeah, so we can just you can deploy it directly here. So basically, we need to use the KNIME server, which we need to add as one of the workspace here, which is not available as of now. Once we do that, we'll get an extension to do the deployment. Okay. So once we deploy it here, it will come up on the KNIME server web portal, where we can do the rerunning of the models, or in case if that model has the visualizations, you can share it with business users. They can start the model and see the visualization outputs directly, right? So that's how it works. Wally, you want to add anything to that?
Yeah, so definitely. So that actually brings us to a very common question, and that's how does KNIME as a company make money, given that our analytics platform is open source and it's not like a freemium or premium version of it. Anyone who wants to download and use the analytics platform, you can. So what we as a company we offer is the KNIME server. It's for purchase. And that's where you would be able to deploy algorithms via PMML or whatever you want. You can schedule your jobs to run. And that's where you have a web portal available to our business users and whoever else would like to use it. And sort of a feature we call guided analytics. So you can build this workflow and deploy it in a UI manner to the web portal.
So, okay. So Joe, I got your question. So after you separate them by cluster, how do you make them by a real persona? So it's more about, see, once we do the two levels of clustering, so once we define the levels in the second step, so we can identify based on the sales pattern. So for suppose, let's take an example of tennis. So if there is a user who is purchasing lots of tennis gear or tennis related products, right? So now based on that sales pattern, we can understand the persona of the user into the sports, right? So the user persona is into the sports, he's interested in the sports. So now we know, based on his sales pattern, we know this guy is interested in tennis. So now we list them in that sport category. And from there, we can give him a targeted and appropriate marketing information through SMS or emails about the tennis equipment or the products in the e-commerce or in the store for the new launches, and also guide for the new services, which is our main agenda here, for probably the new events that the company is driving for tennis, or the new playgrounds that they are on renting purpose. So that's where the persona comes from, and how we can use that, the user's interest, to divert them to the new services. So if you get new data, see, this is a continuous process, Jaya. See, once we schedule the model on daily basis, once we have this ETL defined, so daily we'll be getting the user information, the geographical user information along with the sales. Once we run the model as usual, right? So we'll get a cluster data output. So the clustered output is the label, right? So we're defining the label saying that this guy is a probable customer for us for the new services. That's what the cluster 0 or 1 we defined in the first cluster, which we are saying is player as 1. So the 1 is a label that we're attaching to the user, saying that he's a probable user or customer for us. In the second set, again, we are labeling him based on the pro level, the beginner or intermediate or the expert. That's again done based on the average or the mean calculation that we have done using the K-means output. That's how we label him as a probable sport user, and also he is at this particular level of, proficiency. Yeah. Does it answer your question, Jaya? Okay.
So I think that's time. We're kind of ending.
Yep. So we got a thumbs up from Jay. Okay, thank you. All right.
Okay, guys. I think it's time for the demo to be done.
Just to add one more point. So we can still take questions. If you can share us through portal, I think Lindsay can guide you on that. So we can answer the questions via email if you have anything, and we'll also share the presentation and the workflow with you guys. Thank you.
So Lokesh, Karthik, any closing words? I just want to thank you both so much for your time and our partners at Akira. It's been a blast.
So nothing much. I think it was a great demo from Karthik. Thanks, Karthik, and Wally. Thanks for your support and help, and all the participants who has taken their time out from their busy schedules, and that too, especially on a Friday. thanks for joining us today and taking this out. Of course, we always look forward to answer as many questions as possible. So please reach out to us if you have more questions, or if you want to see an exclusive demo for yourself on this particular use case. We can set up a session out of it. So please reach out to us, and Lindsay will help us to collate all the questions. And if you have any specific interest on a very similar use case, which you want to explore through KNIME, please again drop a note to us, and we'll be able to set up a one-on-one session with you guys. And with that, I want to thank all of you who have joined today, and have a great weekend and be safe. Thanks, guys.
All right. Thank you all. Thanks, Wally and Lindsay, for the coordination. Appreciate it. All right.
Thank you.
Thank you.